guys, here we go. We're going to start with chapter 3, moving right along, okay? So let's get going with chapter 3. Chapter 3 is going to talk all about lines with two lines with a third line crossing, okay? So we're going to call this third line that's crossing the transversal. So when one line intersects two other lines, it is called a transversal. So a transversal is a line that intersects two coplanar lines at two distinct points. A line that intersects two coplanar lines at two distinct points. Line T is the transversal. Okay? As you can see, when this line, the transversal, meets the other two lines, L and M, there's 8 angles that are formed. 8 angles. We're going to call them, for starters, the interior angles, which are 3, 4, 5, and 6, as shown here, interior angles. Hopefully, you see that for obvious reasons. They're inside of the two lines. And, of course, we're going to call the exterior angles, 1, 2, 7, and 8. 1, 2, 7, and 8. So we've got the interior angles and the exterior angles. Pretty straightforward, okay? Now, we have the alternate interior angles. Alternate, which means they're on opposite sides of that transversal. Alternating on opposite sides of the transversal, okay? But they're not next to each other. So they're tagged as non-adjacent interior angles on opposite sides of the transversals. Which ones do you think they are? 3 and 6, 5 and 4. Why not 3 and 4? Because they are adjacent, and we said they have to be non-adjacent, so alternating, like on a diagonal of sorts, okay? Angles 3 and 6, 4 and 5 are your alternate interior angles. We also have a big one here. They're called the corresponding angles. They come in pairs too. We got 1 and 5, we got 3 and 7, okay, got 2 and 6, and 4 and 8. Okay? Now, what do you think is the definition of them? You got to think about it a little bit. There's always an interior and an exterior, all right? So, we've got, let's see, we got 3 and 7. That's one interior, one exterior. Okay, well, we got one interior, one exterior would be like 3 and 8. They're on the same side of the transversal. Okay, 3 and 7, 3 and 7. Okay, same side of the transversal, one interior, one exterior. Why not 1 and 3? Well, 1 and 3 are adjacent, so they've got to be on the same side of the transversal. They got to be an interior and exterior, and they got to be non-adjacent. Remember, adjacent is next to each other. I bet you that's what our definition is. Corresponding angles. Angle pairs formed by a transversal, one interior, one exterior, there it goes, sorry about that, one exterior and non-adjacent on the same side of the transversal, okay? It's a mouthful just describing them, but it's easier to just look at the picture and see, yeah, okay, then we got the correspondings at 1 and 5, 3 and 7, 2 and 6, and 4 and 8. We have the alternate interiors at 3 and 6, and 5 and 7. And I guess we didn't mention them, but we have the alternate exteriors too, which you should presume are, there we go again, 1 and 8 and 2 and 7. Okay? So we got to have those names down. Should be in your vocabulary, all right? Now, here we come with a couple postulates, okay? Corresponding angle postulate, okay? Now, this is strictly dealing with parallel lines, and pretty much everything from here on is going to be two parallel lines cut by a transversal. Two parallel lines cut by a transversal. Here's our indication for the parallel, right? DE parallel to AB. If we get two parallel lines, and we have a transversal slicing through them, we're going to have a postulate. Now, postulate is without proof, okay? But we're going to actually prove it when we look at our sketch pad. We're going to see that it's going to be true, okay? So two parallel lines are cut by a transversal. The corresponding angles are congruent. So you bet, you got it, 1 and 5 are congruent, but they're not the only correspondings. Okay, what else? 4 and 8 are congruent. 2 and 6 are congruent. 3 and 7 are congruent, okay? So, as we say here, angle 1 and 5 are corresponding. Therefore, our postulate, without proof, okay, is that they are congruent. 2 and 6 are corresponding. And our postulate, 3, 1, corresponding angles formed by two parallel lines and a transversal slicing through them, corresponding angles will be congruent. 2 and 6, and you've got it, 3 and 7, and 4 and 8. If two parallel lines cut by a transversal, then corresponding angles are congruent. Okay? Well, once you have a postulate, it's going to lead to some other things which are going to be proofs, which we're going to be able to illustrate. Here again, same picture, two parallel lines, A, B, D, E, cut by a transversal. Okay? Given angle 1 is 120. Guess what? All I need to do is give you one angle, and you can find the other 7. Yes, you can. Give you one angle. Angle 1 is 120. Bet you can, right? Find the measure of all the other angles. Well, you already know you got verticals. You got 120 there at 3, right? Then you know you got supplementaries. You got, so 1 and 2 are supplementary, so 2 is 60. Well, here, we're going to outline it all for you. There you go. 2 is 60. Why? It's a supplement to 1. Okay, always be able to determine why, right? 3 is vertical to 1, and therefore the same as 1. It's also supplemental to 2, so either way you look at it, it's 120. Okay, 4 is 60. Why? A couple of reasons. Vertical to 2, supplemental to 1, supplemental to 3. A number of reasons, right? 5 is 120. Go back to our postulate. Corresponding angles. 1 and 5 are corresponding. Corresponding angles is the link. That's the link between the upper 4 and the lower 4. The upper angles and the lower angles are linked through the corresponding angles. 1 and 5. So guess what? Now we have 5. We have this angle down at the bottom. We know every other angle down here. Every other angle, you got it. It's either 120 or 60. Here they come, and there's the reasons. No big surprise, okay? There you go. We've got every angle in that picture strictly by knowing that we had parallel lines, a transversal slicing through them, and one angle, and with that postulate from the previous page, that the corresponding angles are, when parallel lines are cut by a transversal, okay, corresponding angles are congruent, and here it is, bottom line, right here, it says what? All right, look at that, man. It says, okay, if two parallel lines are cut by a transversal, if the measure of one angle is known, then effectively every angle is known. That's kind of cool. We've got that going for us. Oh, what happened? There we go. Okay, let's get back to the show here. Okay, let's get back to the show. All right, here we go. Okay, next, let's do a proof. You're ready for a proof. Alternate interior angle theorem. Theorem 3-1. We're going to prove it. Yeah, we're ready for a proof. I think we can do it. Let's take a look, okay? If a transversal intersects two parallel lines, then alternate interior angles are congruent. All right? Now, since this is a theorem, it means we can prove it, and we're going to show that. But, okay, if a transversal intersects two parallel lines, there's the same picture. We're going to see that again and again and again and again, all right? So there you have it. Two parallel lines cut by a transversal. What this is going to say is the alternate interiors. The angles at 3 and 5 and 4 and 6 are going to be congruent. Okay, the alternate interior angles. So here we go. Let's take a look at the proof. All right. So given we have these parallel lines cut by the transversal, given 3 and angle, they prove angle 3 and 5. They don't even give us anything. They give us parallels, and they ask us to prove that the alternate interior angles are congruent. And we're going to prove it, okay, based on the only one thing that we know for sure, that corresponding angles are congruent. Now, I know you said, well, wait a minute, I thought you just came up with that theorem. Well, we did state that theorem, but we didn't prove it. So you can prove it, and once you prove it, then you know it's a solid fact, okay? So here it is, parallel lines, all right? Prove 3 and 5 are congruent. If you prove 3 and 5 are congruent, then we got it. Look at it. We've almost done this in one of the proofs before. Set it up, statements and reasons, right? Always start with the given. There you have. Parallel lines are given. That's right. Okay, now what? Look at what I said. 3 and 7 are congruent. Why do I know 3 and 7 are congruent? What kind of angles are 3 and 7? They are what? They are our corresponding angles. And we know corresponding angles are congruent. And so I'm just writing corresponding angles because we know we had a corresponding angle postulate. That's postulate 3, 1. You're not going to remember the number every time, but you are going to remember corresponding angles are congruent, okay? Now, we've got 3 equaling 7. Now, what's the link? We've got to go to 3 to 5. Think about it. We've got 3 equaling we've got 3 equaling 7, and we've got to end up with 3 equaling 5. That's what we're trying to show. How are we going to do it? What's the relationship? Think about it. Look up here. 7 and 5. What are they? Vertical angles. There you go. 5 and 7 are equal vertical angles. Now what? If 3 is 7 and 5 is 7, makes sense that 3 is 5, transitive property, right? There you have it. There's a proof. Not so bad. Let's see another one, okay? Same side interior angle theorem. Same side interior angles. Well, think about what it is. Same side interiors. Would it be 4 and 5? Yeah, they're same side interior. 3 and 6? Yeah. Okay. So theorem 3-2 says that if a transversal intersects 2 parallel lines, then same side interior angles are supplementary. Meaning, of course, they add the 180. Okay, if a transversal intersects 2 parallel lines, then same side interior angles are supplementary. Okay, now that's the theorem. Let's see if we can prove it. Given that we start off with the parallel lines, show for a fact that the angles 4 and 5 add the 180. We could have picked up 3 and 6, would have made no difference. Okay, 4 and 5 are 180. Let's do the proof. Where does this statement come from? Well, it's given, right? Okay. Now, how are we going to show 4 and 5 are supplementary? We can pick up any kind of other supplementary angles, okay, and then we can do a substitution. So we've got supplementary angles all over the place here. Invariably, any 2 angles that are adjacent are also supplementary. Okay, so what am I going to pick up here? I'm going to say, well, it looks like I'm going to start with the corresponding angles right there. Okay, 1 is equal to 5. Okay, so 1 is equal to 5. We know that, corresponding angles. Now, here comes one pair of supplementary. 1 plus 4 is 180. Why? Why are they supplementary? We know they're supplementary. They are a linear pair, so they are supplementary. So you could write linear pair, just write supplementary angles. Now, one step away, you're looking at it. What are we trying to show? What do we have down here? Simple substitution, right? Simple substitution. You got another theorem under your belt. You got another proof under your belt. There you go, guys. Okay, watch that again. You need to. There's some vocabulary. We're going to do some proofs. We're going to look at some more of this stuff tomorrow. Okay, good. Don't forget to outline section 3-1. That's all for tomorrow. Thanks, guys.